We want to find the volume of the solid obtained by rotating about the x-axis, the region under the curve y equals x to the 1/4 from 0 to 5. So I went to our disk washer program. I put in f of x is x to the 1/4, g of x is 0 because we want the region under it. That means all the way down to 0. And then it graphed right here, two-dimensional flat image. This is f of x or y is x to the 1/4. Okay, right there. And it graphed it, and then it took it over here and rotated it about the x-axis. Can you see the axis? This is the x-axis right here. This is the y. It's the y. So, because that's what they told us to do. Find the region. You want to find the volume of the region obtained, the region about the x-axis. So we're rotating it about the x-axis. We're going to get this circular kind of thing. We want to find the volume of it, the volume. How do we do it? Well, we're going to fill it up with discs. Remember how we took flat rectangles and filled up to estimate area, and that became an integral? Well, now we're going to do it three-dimensionally, except each of these rectangles, when rotated, notice becomes a disc. This is a partial rotation. I stopped it part way at 275 degrees of rotation so you could see the disc shape. So there it is. So we have to find the volume of all of that. Well, to do that, we're going to have to find the volume of each disc. Well, how do you find the volume of each disc? How do you find the volume of any disc? Well, if you have a disc, notice it's round. So the top of it is pi r squared. That's the area of the top of any circle times the thickness. And what's that? That's going to be dx, right? You can see it right here. Each of these discs is dx. Like that. There it is before it's rotated. Here it is dx after it's been rotated, right? We're going along the x-axis. The thickness of each disc is dx. And the top of it is a circle, which is pi r squared. So to find the volume of each one of these disks, take the top area times the thickness, pi r squared times the thickness. That's how we do it. So and we'll get the total volume of each disk. And then we just need to add up those disks, right? That's what the integral is all about. It's add up the disks from here to there, from 0 to 5, from 0 to 5, add up the disks, and each disk's volume is pi r squared dx, right? Just popped it right there. Okay, but the trick is, what is r? What's the radius of each disk? Well, the radius of each disk is, you can see it right here. There's a radius. It's this height there. Any of these. You could do a radius right over here. Here's another one. Right? A radius, that's the radius of a disk. What does radius mean? From the middle to the edge. So the radius of a disk, let me erase this bottom part so it does look better. So the radius of a disk goes from the middle to the edge, from the middle to the edge. So for each of these disks, from the middle to the edge, from the middle to the edge, from the middle to, these are all radii. They're getting bigger, right? For each of these disks from the middle to the edge, that's the radius of the disk. Now, what is that though? Well, that's bringing it over to the two dimension. There's the radii, and each of those is the y value. Y is x to the 1/4. It's the height, right? Whenever you go from the axis up to a graph, that's called the y value. That's also called the radius. The radius is the y value. So therefore, this becomes y squared. This becomes the integral from 0 to 5 of pi y squared dx, because the radius is just y. But the problem is we can't have y and x mixed here. What is y? Y is x to the 1/4. So this will become x to the 1/4 squared. All right, and then simplifying one step there, it's integral 0 to 5 pi. That'll be x to the 2/4 dx. And there's our integral. There's the setup of the integral that'll find the volume of this three-dimensional shape, which is formed by taking a flat two-dimensional shape and rotating it about the x-axis. How do we get it? Well, each disk is got its top area, pi r squared, times its thickness, dx. And then pi r squared times dx, the r, the radius, is from the middle to the curve. Y equals x to the 1/4. So this y becomes x to the 1/4. So radius squared is x to the 1/4 squared, because the radius is x to the 1/4, which is x to the 2/4. And so there we go.